Okay, so my name is Ahmed Abou-Alfotouh. I'm from AMD, and today we're going to go over the Open Accelerator Infrastructure, or OI project overview and workstream update. Beyond me, this is again Ahmed Abou-Alfotouh from AMD. I have Song Kok from Meta. I have also Anthony Chen from Meta. Also, Anthony is a Power Workstream lead. Song is another OI project co-lead. Bichen is not here today. He's a signal integrity or high-speed workstream lead. And Chen from HTC, he's a system workstream lead also. The agenda that we're going to cover today is the OI sub-project overview, what we are doing in the OI, and what are the contributions that within the OI workstream. And then we're going to give update about the high-speed and system workstream, and also the power workstream update. People who don't know about the OI formed officially in March 2019. Even there was a contribution before that, but officially formed in March 2019 under the OCP server project. And the goal was from the OI is to define and build infrastructure for fast updating upcoming product for OI and HPC application. We have 5 work streams under the OI: the high speed, system, power, cooling, and OM tool. Where we're standing today, early this year, we released the OM 1.5 and UBB 1.5 spec. And all of the work stream are working hard to release the 2.0 and the OM 2.0, the UBB 2.0, and also the expansion 1.0 spec. We have 7 boards contributing from the OI. People, maybe you are not familiar with everything. Common or familiar is the OM and UBB, but there are other cards that we are also working on beyond the OM and the UBB. So there is an expansion, the HIB, or the high interface board, the PDB, the SCM, and the OI tray. So 7 contributions coming from the OI work stream. There are a lot of members right now. It's growing every year. Every year we're growing. We're adding more members, and some of them active, some of them not. And hopefully we add more contributors and more active members. We need more members. We need more active members to participate in the OI. OI is growing, and really the contribution of the OI, we start seeing a lot of fruits in the industry today. And we need more and more members and contributors to the community. This is the timeline of OI. As I said, the contribution started from Q4 2018 with the OM concept. And it was 25 gig NRZ, the PCIe Gen 3, with only 450-watt card, air-cooled only. Looking for Q4, by the end of this year, we will have OM 2.0, UBB 2.0, the expansion card 1.0 for the first time, going from 25 in 2018 to 112 gig PAM4, PCIe Gen 3 to PCIe Gen 5 and 6, from 450 watt to 1 kilowatt. This is a big jump in the power also, from air-cooled only to air-cooled and liquid-cooled. So a lot of projects going on, a lot of contribution from the OI, and we need more and more contributors and active members to participate in the OI. And now I would like to hand it to Song to give us about the status of some of the projects and high-speed work stream.
All right, thanks, Ahmed. Hi, everyone. Yeah, I'd like to provide some update on the high-speed and the system work stream. First, I think I would like to talk about the OM 2.0. We have been working on the 2.0 since last year. And we have made some adjustment on from the OM 1.0 to 2.0. The form factor is going to be slightly different in terms of the platform width. So we increased it to 70 by 102. And we also looking into the 1 kilowatt, right? And we are adding a more power entry from the connector side. And now the OM 2.0 support the dual power entry. So it can actually, it depends on the configuration. If on the thermal boundary condition, you actually can using a 1 power entry to serve 1 kilowatt, or you want to split it to the 2 connector. So this is the feature that we're adding into the 2.0. And also for the input voltage, we are keeping the input voltage 48, 54 volt the same, but increase the current consumption. And we're going to keep the 3.3 volt for some of the board management power rail. And by getting some of the feedback from some of the OEM supplier, we're going to keep the 12 volt as an optional, and they might use that 12 volt for other purpose as well. And besides, I think on the 2.0, we also adding the connector. So we are moving from Mirror Mesh to Mirror Mesh Pro. We support the 112 gig, but consider the thermal and the power delivery to the OEM. We are providing a second option that for the stacking height of the connector, you can go with 5 mm or 8 mm, depends on your OEM design. And the SerDes speed that we also bump to the 112 gig PAM4 long reach and also the PCI Gen 5. And moving on, the connector itself is going to be supporting the PCI Gen 6. And moving on, the UBB 2.0. UBB 2.0 is one of the major work in the Workstream. And we are keeping the width of the card with the 417, similar to the 1.0. But we increased the length of the card to 655. What it means is that we are actually adding more feature or function to support the UBB. And one of the things that we are adding is the expansion module. That's why that the card is getting longer. But it depends on your implementation. If your design or your implementation doesn't require a direct scale up from the OEM, you can always string down the UBB to whatever form factor that you want. But there is a catch on that one. As long as your UBB tray design is going to be compatible with the tray design. And one thing that I would like to mention is that the UBB 2.0, we are, as you guys know, that NVIDIA contributed their HGX baseboard form factor into the OCP. We're going to leverage the connector location pin map into the UBB so that we can have both systems to be pin compatible between the same chassis. So those are the work that currently has been looking into the detail how to implement both solutions into a single chassis design. And so as I mentioned before that we're going to support the additional platform, and this one that we call out is called the expansion module. So from UBB 1.0, as you can see that we only support the 8 scale up in terms of the QSFP or OSFP. But for the UBB 2.0, we increase the scale up port from 8 to 32. Or depends on your thermal boundary condition system design, you can actually increase more than that. But from the OAI work group, we are only target for 32 scale up port. And besides, we're also adding the root of trust security module into the baseboard, not just the baseboard. I think for overall OAI spec, we're going to heavily involved into the security, which is one of the major requirements from the end user. And the end-to-end loss budget, we're still targeting for 28 to 30 dB, but with the bump of the SerDes speed to 28 gigahertz. Expansion module 1.0. So this is a new platform that we define in the OAI work group. The dimension here is a 160 by 138.87, which is roughly 140. I'm sorry, this is the typo over there. So the 138.87, and it's the card itself, but if you include the connector height, that will be a 148. And this board is going to support the same power delivery. We're going to support the 48 volt and 3.3 volt. The TDP can up to 400 watts. And the expansion module can use for multiple application, right? I think one of them is like you can have the file retimer direct scale up from the OEM. And another config that you can have is the crossbar switch config. So you can have a different topology on the baseboard combined with the expansion module for the OEM. So it depends on the end solution implementation. We provide the flexibility in terms of the architecture for the end customer to design their system. Other than that, other config can be also support, because what happens is that the way that we define the interface to the baseboard, that we have 8x8 high-speed SerDes interface, which is supporting the 112 gig. And we also have a sideband signal, which is like out-of-band I2C, SPI, and MDIO. And at the same time, we also supporting the in-band management through the PCIe by 4 as well. So the other config can be a NIC or remote memory and more. So when we talk about the CXL, this is another thing that the CXL can play into the role of the OAS system. All right, I'd like to talk about what in the high-speed workstream. As you know, that 112 gig is quite challenging for the end-to-end to meet the loss budget target and crosstalk, etc. Right. So by looking at the UBB plus the expansion module OAM design, so what we are looking into is that for the scale-up topology, and we are looking into like 13.5 inches each. And with the latest PCB material with the 0.85 dB per inch, we should be able to get the loss budget between the 11.5 dB at the UBB side. And for the scale up, which as you can see that in the red color, right, that is the longest path that you're going to route from the OAM to the expansion module, which is around 18 inch. And with that, we are going to get the worst case channel loss of the 15.5 dB. And as when we come up with why we will talk about 28 to 30 dB for the OAM to OAM and OAM to expansion module, that's how we define that in terms of the loss budget on each different platform, right? For the OAM, we're still going to target 8 dB for the OAM, and UBB is going to be 12 to 14, depends on your SerDes performance. And expansion module is much more simpler than OAM because we know, because with the retimer, right, the small package, the loss on the package is slightly less than the OAM side. So we're going to target 6 dB on the expansion module. And we have run some of the COM result and which showing very good result from the COM. And we actually, from the workstream member, we have been looking into more on the Chen assessment, and we actually have from Broadcom, right, and with the retimer, and from the Miramax Pro Marlex, and for the XRMax, we actually doing the end-to-end channel analysis from the OEM to the retimer, and also from the retimer back to the OEM. So with the worst case data and cross-off pattern, right, and then with some assumption on the AC package loss budget plus the retimer loss budget, and also adding some of the gap band and like such as the jitter, the noises, and etc. And that's the whole end-to-end channel assessment. We are actually doing more aggressive and try to understand what is the outcome and whether we can be able to support that up to the 112 gig. And this is the result that we got, right? I think for the loss budget, we're still targeting for like 28, 29 dB loss. And what we got in the return loss is around like 15 dB. And this is the result that what we got for the summary of the BERT and also the SNR margin. And from the simulation result and the ASIC to the retimer to the ASIC, the loss budget, what we got is around 28.7. And for die to die is a 35.3. Like what I mentioned before, the assumption on the package routing in terms of the loss, right? We just added up to the simulation here. And what we got on the prefab BERT is like 2e to the minus 7 or 3e to the minus 7. And the SNR margin is like 2.2 dB. So with that, I would like to pass it to Anthony to provide the update on the power workstream. Thank you.
Thanks, Long. Okay, yeah, so from the power workstream, can I give a quick summary of some of the things we've been working on in the past year? Similar to the other areas, we've made a lot of efforts in exploring the UBB 2.0 power architecture, including, of course, the UBB, PDB, and also focusing on the expander module, as was mentioned earlier. And from the OEM specifically, we'll look at some of the updates to the EDPP. Excursion power continues to be a challenging aspect for us to deal with, especially with the drive towards 1 kilowatt designs. And also with help from some of our Power Workstream members, such as Renesas, they've also helped to provide some of the placement, kind of study and looking at some of the challenges and options that we might be able to achieve with this new 2.0 revision. So first, looking at the OAI, UBB, and PDB power architecture, we showed something very similar to this in the previous year. But there are really a couple of main changes that have been added. One is we're really trying to consolidate the 48 and 54 volt power domains to really reduce the overall power footprint. One of the major changes you'll see, of course, is the fact that we no longer have as much 12 volt domains on the board, right? So effectively giving us a lot more copper routing on the UBB itself to deliver the power. And also with the OAI expander that we added to do the scale out, that is quite a significant power increase as well, right? As we have a 400 watt TDP maximum with 8 cards in the front, right? Another thing, of course, also is introduction of the OAI PDB. So I think this is something that's new and mainly looking to support some different use cases, such as hot swapping, ease of service, stuff like that, right? And one thing that we have been discussing in more detail in the recent times is the proposal to actually develop a regulated 48 or 54 volt stage on the PDB to really enhance the end-to-end efficiency. That way, when we're doing UBB designs and OEM designs, we don't have to support a wide 48 to 60 volt range. We can really optimize in and pick specific nominal voltage there. So lots of discussion going on there. From the OAI expander module, we've done a lot of study on this aspect as well, since it is a new board to us. We worked with a lot of different, retimer, PCIe switch vendors to really understand what sort of solutions we could enable on this form factor. As Song mentioned, we have a target TDP up to 400 watt, but of course, we're actually studying both 200 watt and 400 watt versions, depending on whether you'd like to use a retimer or a PCIe switch. We looked at a couple of proposed power trees. This is what we kind of used as a kind of leading vehicle to look at the solution space. And yes, and this card, of course, is going to be 48 and 54 volt and also 3.3. Again, really trying to minimize the 12 volt usage where we can and really consolidate to using 48. Okay. Another thing that I mentioned, of course, is excursion design power. This continues to be a very challenging aspect in the industry to design high performance, high power GPU or ASIC designs, right, for OEM. So what we showed in the background in the red is something that we were discussing since last year. We've had more iterations on this particular aspect, and there has been recent release from the PCIe SIG community with regards to EDPP, and we're trying to discuss whether it also makes sense for us to follow kind of like a power versus time curve opposed to having staircase functions, right? So this is definitely something we really want to hear from the community, not only from ASIC and GPU vendors, but also power solutions. We want to know whether this is really the best way for us to define an ecosystem where we can enable broad market of products. All right. So from power design is a really big challenge for us. 1 kilowatt design in such a small form factor. There's a couple things that really point out to us when we started doing some of the solution studies and surveys, right? So VPD, vertical power delivery, is a new technology trend, likely you've seen from many vendors, but it does require big effort to really make it mature in a way that we can reach mass production and scale. And also another aspect of we've seen earlier in the slides is the large ASIC package does limit the size on what's available for us to perform the power solution placement, routing, and cooling and all of those things. And often there are a lot of mounting holes to create retention plates and things like that for liquid cool plates or air cooling solutions, right? So again, less space for the routing, right? And another aspect I think we're trying to investigate as well is whether package overlap with the connector is something that we can support, right? So that's pending more SI analysis that we'll share at a later time. Yeah, so looking at some of the, again, this is not the only possible solution, right? Again, we really want to work with the industry here, so if there is any solution or topology you'd like to explore, please reach out to us. But this is one of the options that we do see quite popular, right? And we call it kind of the side strip approach, where we place all of the power converters at the north and south side of the chip, really maximizing the space for SI routing in this way. And of course, this would require us to put the inductors on the bottom side of the board, which is where that 5 and 8 millimeter space really comes in handy. Right now, we're targeting roughly around a 33 amp per phase on the high side. We think it's still manageable, but of course, as Song mentioned, a lot of thermal boundary conditions need to be explored as we move forward. Another approach that seems to be quite popular, looking at some of the OAM 1.0 designs, is actually to do side placement where we also use the west and the east side. This helps us to support a higher TDP if required, right? Really maximizing the space. And again, inductors can still be placed on the bottom side. All right, so yeah, that concludes our update, for the OAI project. Feel free to get involved, join our server project group, mailing lists. We have monthly meetings, and also all OCP community members are, more than welcome to join our work streams.
Thank you.
So we open up for the Q&A if we still have time.
Mic is not open.
I'm going to shut out. Maybe you can hear. I'm going to speak loud. So a real quick question, right, on for the OI to OAI connection. I mean, are we thinking or at least moving to exploring optical interconnect between the two modules? Is this something that you're interested in talking about?
Yeah, this is a good question. Let me repeat your question again. You're talking about the optical.
It's working again.
Okay.
All right. Okay, well, the question was module to module interconnect. Are we looking at exploring optical interconnect between the modules?
Yeah, I think that is a good question. I think we have been looking into that. I think we do see some challenges because of the service availability, like from the OEM to OEM. If you look at the OAI, the UBB system, right, it is a very dense system. And by doing the optical to optical interconnect, right, that is another challenge that we're looking into. Because right now, if you look at the optical co-packaging technology, right, it's still very early on. And we still need to see what is the industry trend to be at the final form factor, right? Some other company have like a pigtail, some other company have some different solution, right? And some laser module will be integrated versus separated. So those are the things that we're still looking into, what is the right solution that we want to implement on the OEM, or we can say that on the baseboard, right, on the UBB. So it could change the whole game for the optical from the electrical side, and the OEM might become a different form factor, but we can still utilize the same system, right, to upgrade to the optical. So those are the things that the Workstream is currently looking into and waiting for the industry to come to be mature. Yeah.
Thank you.
Hello, is this one on? Okay. So I had a question actually on this slide. So it says it supports a root of trust security module. Is this separate from the DCSCM, and is this something that's going to be OAI specific or something open to more OCP projects in general?
So this is something that we actually try to engage with the DCSCM, and this is, I believe this is a similar security module. But we do looking into like a very simple design, right? Just doing a very like power on, like a security check, etc. But we're still open for all the feedback from other workstream as well. Right now we do have a proposal, but we are not talking about that in this conference. But we're going to willing to talk to other group, and then we have a team member actually approach to other work group, right? Try to get their feedback and if this is the right thing to do on the baseboard itself, right? But for the OEM, we are going to rely on the supplier to implement the root of trust on the module level. We are not going to control that, but we do put some requirement in the specification. But for the UBB, for the expansion module, this is something that the workstream is looking on and try to work with the other work group to come up with the solution.
Thank you.
I have a question about the last slide. Can you go to the last one?
This one?
Yeah, I see the IBC.
Yes.
Did you specify the IBC? Is it a part of multi-source agreement?
I can comment on that.
Okay.
Yeah, again, we are not specifying the specification of the components on the OM. We are specifying the components specifying the requirement for the OM itself, like the input power, the excursion power. This is a study from one of the vendors who is actively working with the workstream to see is there a solution that can deliver 1 kilowatt or not? Is it doable or not? And we are encouraging more and more power vendors to work and give solutions, but we're not gonna specify the component specification on the OM. Does this answer the question? Yes. Thank you.
All right.
Any more question? Okay.
Okay.
Thank
Thank
you
you, guys.
Thank you.
Thank you, everyone.